I am back with one more previous year question, and this question is from electrochemistry chapter. As you can see, this was asked in 2019 NEET. And if I give you the essence of this question, we'll be solving this question, or the concept behind this question is Kohlrausch law. So we'll be talking about Kohlrausch law briefly, then we'll apply this Kohlrausch law to solve this question. Let's see how to solve this. First of all, let us see what is the essence of this law. Why do we need why did we need this law? Or what was the need for us to start with this law, isn't it? So actually we failed to find lambda m naught of V calculates. So we could not find limiting molar conductivity of V calculates using graphical method. We could do that for strong calculates, but for V calculates we couldn't do that, isn't it? So we needed an indirect method to help us in calculating this limiting molar conductivity of V calculate. And this is where our Kohlrausch law helps us in finding lambda m naught of V calculates. And in today's question, they're asking us limiting molar conductivity of acetic acid, which is an V calculate. So this is what we are supposed to find: limiting molar conductivity of acetic acid. Now we know from Kohlrausch law the limiting molar conductivity of any alkylate. Limiting molar conductivity of any alkylate can be written as the sum of the limiting molar ionic conductivities of ions, isn't it? So in acetic acid we have two ions, acetate ion and H plus ions. So I can write this as sum of limiting molar conductivity of acetate ion as well as H plus ion. Now we are given three different alkylates, which all of them are strong. So H2SO4, K2SO4, CH3COOK. So we are given three alkylates along with their limiting molar conductivity values. Now using these three, we have to somehow, by using some algebraic operation on these three, we should end up with this one. So how to do this? I'll give you a trick. So among these three salts, we have to choose first those salts in which our ions are present. For example, our acetate ion present in potassium acetate. So first I'll take this. So it is lambda m naught of CH3COOK. Then our H plus ion is present in H2SO4. But the problem is here, to make H2SO4 is to make CH3COOH, I need only one H plus. But in H2SO4 there are two H plus ions. So what do? I take half of the required amount. So it will be half of lambda m naught of H2SO4. Then I'll take half of lambda m naught of H2SO4. Alright. Now if you look here, we need only acetate ion and H plus ion. So we got acetate ion from here and we got half H plus ion from here. Then there are other ions which are unwanted. For example, potassium ion is extra here and half sulfate ion is extra here. So what do? I have to remove them. And how do I remove them? By subtracting the salt which contains both these ions, which is nothing but potassium sulfate. So again, I have two potassiums here, but I am looking for only one potassium. Again, I have one sulfate ion, but I want only half sulfate. So what do? Again, I take half into lambda m naught of K2SO4. That's it. We are done. We simply substitute these values which are given to us, and we are done with this question. So potassium acetate, the value is Z, and H2SO4 the value is X, and since we are multiplying it 1 by 2, our rate is X by 2. Then minus K2SO4 is Y, so it is Y by 2. So what is the final answer? It is Z plus X minus Y by 2. That's it. So this is our answer.